So we left off yesterday. Had a 2-hour class, so we squeezed a lot of stuff in there. So I want to review some of it. First thing I want to review is our negatives, because that always seems to be a struggle. We'll start out with something like this: 8 plus a negative 6. Can anybody tell me just off the top of their head what that is? Positive 2. Good. Now, if you don't know that, you can always go to those vectors, those arrows. Make a 0 point on your page somewhere and use the arrows. Positive 8 goes in the positive direction, 8 units. Negative 6 would be the negative direction, so it's the opposite direction, so it's going to go this way. And then you have to ask, is it longer or shorter than the 8? It's shorter, so we're going to stop before we get back to 0. That's the negative 6. So what this picture tells us, we're on the positive side of 0, so the answer is positive. And since the arrows go in opposite directions, it's the difference between 8 and 6, which is 2. So if we have larger numbers there, like a negative 184 plus 73. We set our 0. Here's negative 184. Positive 73 goes the opposite direction, longer or shorter? It's going to be shorter. So this tells us that we're on the negative side of 0, so the answer is negative, and the result is the difference between 184 and 73. So we're just going to subtract. 184 minus 73 is 111. That's a negative 111.
When you change that just from what I seen on the YouTube thing,
Yep.
would you do minus or negative 184 take away?
You're thinking subtraction. When we're doing addition, you don't have to change anything.
Okay.
When we do subtraction, that's when you have to worry about adding the opposite.
Okay.
Yep. So let's say we have a negative 123 plus 485. So again, here's 0. Negative 123 goes this way. 485 is positive, so it goes the other direction. Longer or shorter? Longer. So that's telling us our answer is on the positive side. This is a positive answer. And it's the difference. The arrows go opposite directions, so it's the difference between 123 and 485. So we take the bigger one minus the smaller one, 362. So it's a positive 362 is that result. Subtraction is where things got ugly. 9 minus 2, now we've done subtraction with positive numbers most of our life, so we can handle that. 9 minus 2 we know is 7. But technically, as we said, subtraction is not really an operation in itself. Subtraction is a shortcut for adding the opposite of whatever that number is. Saying subtract 2 is the same as saying 9 add the opposite of 2, which is negative 2. So then we're back to being able to use our vectors. There's positive 9. Negative 2 is the opposite direction, but shorter. So our answer is positive 7, which is what we had from doing the subtraction. So if we have a negative 19 minus 7, that one could be a little tricky. A lot of people would want to yell out negative 12, but that becomes negative 19 plus the opposite of 7 is negative 7. And now we see we've got a negative 19 and a negative 7 both going the same direction. That tells us our answer is negative, and it's 19 plus 7 or 26, so negative 26. Or 34 minus a negative 15. What's that going to be changed to? Yeah, 34 plus the opposite of negative 15 is positive 15. That's just 34 plus 15, which we can do without the vectors, which is 49. Negative 28 minus a negative 19 is going to become negative 28 plus the opposite of negative 19 is positive 19. Let's draw our vectors here. We've got a negative 28. Positive 19 is the opposite direction, but shorter. So our answer will be negative because it stays on the negative side of 0. The difference between 28 and 19 is 9. So negative 9. Make sense? For now? Okay. To me, there's the two most difficult topics in pre-algebra. This is one of them. This is probably the second most difficult topic, is subtracting with negatives. And I can see on a couple of your faces, you're like, there's something worse than that. It's only day 3, don't worry. That's probably the second most difficult. The first most difficult topic is the topic we're going to cover on Monday, which is translating words into algebraic formulas, taking word problems and turning it into an equation. And we're going to start that on Monday, but then throughout the semester, we're going to keep coming back to that and practicing it more and more. I know when I say word problems in math, a lot of people cringe, but you have to remember, in life, your boss is not going to walk up to you and say, what is negative 28 minus negative 19? There's going to be a situation that you have to draw the information out of and figure out how to use it. So in life is a series of word problems. So we're going to have to get used to them. And they don't hurt near as bad as it sounds. We break it in pretty slowly. So then the next step would be multiplication. What would be negative 9 times 7? Well, we have two steps. Figure out whether the answer is positive or negative, figure out the sign of the answer, and then do the multiplication. So the negative only plays into the sign of the answer. We have a negative times a positive, which will be a negative. So now we just do 9 times 7, which is 63.
It'll always be a positive or a negative?
Yep, a negative times a positive will always be a negative. If we have 4 times a negative 8, a positive times a negative is going to be a negative. 4 times 8 is 32, so that's a negative 32. How about a negative 9 times negative 5? Is that answer going to be positive or negative? It's going to be positive. When we have two negatives multiply, always make a positive. And now what is 9 times 5? 45. So it's a positive 45. So some for you guys to yell at the answers for me. Negative 12 times 6 is going to be, first of all, positive or negative? Negative. And the answer, 12 times 6 is 72. 8 times negative 11. Negative. 88. Good. 8 times 11 is 88. Negative 14 times 3.
Is it 50? What was it, 2?
42. Positive or negative? It's a negative. Good. Negative 7 times negative 6. It's a positive 42. I think you've got that down. Let's jump right into dividing. Same rules as multiplication. 18 divided by negative 6 is going to be, first of all, positive or negative? Negative, and 18 divided by 6? 3. Negative 27 divided by negative 3. A positive. A negative divided by negative is positive. 27 divided by 3 is 9. Don't know why the parentheses are on the 7. It's positive. Negative 42 divided by 7. Negative 6. Good. Not so bad? Okay. Order of operations. Where do we start? What's our first level that we operate on? It's always in closing symbols, and in this case we have parentheses. Now, when there's more than one of the same level, we always go left to right. So from left to right, here's our first parenthesis. We have to find its other half, its mate, basically. Is it this one?
Nope.
Nope, going the wrong direction. This one's the right direction. Is it the right one? No, that goes back over here. This is its other end. So we got to start inside that purple box. Now some of you are thinking, yeah, but we need to go in the inside. Yes, we do. Inside this set of parentheses, our order of operations still applies. We're still looking at that first level. Are there any enclosing symbols? Yes, there are. This parentheses right here is another enclosing symbol. So now we have to start inside that parentheses, inside the red box, if you will. In there, are there any other enclosing symbols? No. Are there any exponents, powers or roots? No. Multiplication or division? Yes, there is. So the 2 times 3 is multiplication. We're going to replace that with a 6. Now all that's left inside that parentheses is 8 minus 6, which is 2. So once we have reduced everything in the parentheses to a single number, and yes, I know I'm being lazy and not rewriting the whole problem every time, but it's okay to be lazy every now and then. Now that we've reduced everything inside those parentheses to a single number, I don't need these parentheses anymore. However, when I take those parentheses out, I have this 2 sitting there. What's implied there? Multiplication. That's 2 times what's in the parentheses. So in this case, 2 times 2. Now I'm working inside that next set of parentheses. What was the purple box up here? Inside there, order of operations still applies yet. Any other enclosing symbols? No. Any exponents, powers or roots? Yes, there is. 5 squared is 25. So we take out the 5 squared, replace it with 25, and everything else stays the same. Now I'm just rewriting what's in the parentheses to save a little time. Any other powers or roots? No. Next is multiplication and division. And there's a couple of them, so again we go left to right. This one's first. 2 times 2 is 4. Next would be 7 times 4 is 28. Now, just so I don't lose the rest of it, I'm going to rewrite it here once. I've done all my multiplication and division inside the parentheses, so now I can add and subtract. Again, since they're on the same level, I go left to right. So starting on the left, 3 plus 4 is 7. 7 plus 28, 35. And 35 minus 25 is 10. Now again, everything in that parentheses has been reduced to a single number. So I don't need that parentheses anymore. When I take them out, do I have to put in multiplication? Yes, I do. At least at the front side, I have to put in the multiplication. There's always subtraction on the back side, so I don't need to put anything in back there. Now what's next? Is there any other enclosing symbols? No. Any powers, exponents, powers or roots? No. Multiplication or division? Yeah, 2 times 10 is 20. Since there was more than one multiplication, again, I'm going left to right. Now I have the 3 times 2, which is 6. And I'm down to just addition and subtraction. So 7 plus 20 is 27. Minus 6 is 21. That's it. See how simple it is? I know I'm twisted.
Is there any way to get that glare off this thing?
Unfortunately, no. Okay, so that's just a quick review of our order of operations. What I want to do now for a few minutes is I want to talk a little bit about properties of numbers. Things that you probably know but have never put words to, and the book is going to put words to them, so I want to get them out there. The first word I'm going to throw out there is commutative. I don't so much care that you know the word commutative is that you know that you can do it and when you can do it. But however, the book will talk about commutative properties, so it's nice to know the word. But all the commutative property is telling us is that there are some operations where we can switch the order of the numbers and some operations where we can't. For example, if I have 3 plus 9, what do I get? 12. Would it make a difference if I switched those numbers and did 9 plus 3 instead? No, it does not. So addition is commutative. Likewise, if I did like 7 times 4, what do I get? 28. If I switch those and did 4 times 7, do I get anything different? No, I still get 28. Therefore, multiplication is commutative. Our byproduct operations, remember we talked about how subtraction and division really aren't operations, they're just byproducts of addition and multiplication. If I have 9 minus 3, I get 6. But if I switch the order, 3 minus 9 is going to be negative 6. Subtraction is not commutative. Similarly, 8 divided by 4 is 2. We don't even know how to do this yet. 4 divided by 8 would be 0.5 or 1/2. Division is not commutative. Basically, because addition and subtraction are really the two main operations. Addition and multiplication are the two main operations. Most rules only apply to addition and multiplication. The subtraction and division are the byproducts, or the reverse of addition and multiplication. So the rules don't necessarily apply the same to them. The next property we could have is called the associative property. The associative property applies when there's more than two numbers that we're using. For example, let's say I have 2 plus 5 plus 3. Does it matter? Most of us, we go 2 plus 5 is 7, plus 3 is 10. But we could, because it's all addition, we could go 2 plus 5 is 8, or sorry, 5 plus 3 is 8, 2 plus 8 is 10. We're going to get the same answer. That's what the associative property is saying. Is when we have three numbers in the same operation, it doesn't matter whether we go first two or the second two, the first. That applies for addition. For subtraction, not so much. If we had 8 minus 3 minus 2, well, 8 minus 3 is 5. Minus 2 would be 3. But for 8 minus 3 minus 2, if I did the second part first, 3 minus 2 is 1, 8 minus 1 is 7. That does not work. Subtraction is not associative. So all that's saying is you can't do it, you can't change around orders with subtraction. But for addition, you can change the order of which part you do first. If it's all addition, and that's only if the only operation involved is addition. For multiplication, it works the same. If I have 2 times 3 times 5. 2 times 3 is 6, times 5 is 30. I could have also done 3 times 5 is 15, 2 times 15 is 30. So multiplication is associative. When you have more than one multiplication in a row, you can do them in whichever order works easiest for you. Division, you can probably guess by now, is not. For example, 27 divided by 9 divided by 3. Well, 27 divided by 9 is 3. 3 divided by 3 is 1. We had 27 divided by 9 by 3. If we did the 9 divided by 3 first, would be 3. 27 divided by 3 is 9. Division is obviously not associative. Division and subtraction must be done left to right. If it's all addition and all multiplication, we can go in any order we want to. That's what the associative property is telling us. Now be careful with that, because we still cannot mix operations together. If we have 3 plus 7 times 8 plus 9. We'll look at it and say, well, it's all addition and multiplication, so that's associative. We do it in order we want to. That's not true. It's only if it's all addition or all multiplication. We can't mix and match addition and multiplication. Here, order of operations tells us we must do the 7 times 8 first. Now we've got 3 plus 56 plus 9. Now at this point, it is all addition. So now it is associative. We could either do the 3 plus 56 or the 56 plus 9 first. But technically, it's more appropriate, if we can, to go right to left. 3 plus 56 is 59. Plus 9 is 68. Any questions? Okay. I know there are still like 17 minutes left of class. How many of you, is there anybody here that has not managed to get registered in my math lab yet? Everybody's in there? Everybody's got it working? Have all of you been in there and started the homework? Yes? No. Not yet? Okay. So what I want to do is I want to give you the last 15 minutes. If you want to use the computer lab next door, you're welcome to it to log in. Make sure you can get logged back in and find the homework. Otherwise, that's going to be it for the class today. There is no new assignment. There's just the homework from yesterday that's due on Monday. Now, if you're doing the homework, by the way, for those of you that don't, that read better out of a book than off of a computer, which is definitely me, unfortunately, the assignments still have to be done on the computer, but if you're working along here and there's a problem that's got you stumped and you'd want to look in the book and work on it, there's a little trick. The homework actually tells you where to go. I'm just going to pick one. Let's pick homework 3 here, and let's say I'm working on problem number 29 here. And let's say I get stumped on problem number 29 and I don't want to use all the stuff on screen. I want to just look in my book and figure it out. Right up here at the top corner of the problem, it says 2.1.47. What that is telling me is, this is chapter 2, section 1, question number 47 in the book. Now, it won't be the same numbers, but it'll be a very similar question. So if I'm tired of staring at the screen trying to figure it out, I can grab my textbook, go to chapter 2, section 1, problem number 47 at the back of that section. And that'll be a similar question. It'll help me. I can use it.